I'm going to do one more problem that has a little bit of a kind of an interesting thing going on. You see how it says x cubed plus x? When we go ahead to do long division, we want to make sure that all the terms are in standard form. So we want to write x cubed, but we also want to write plus 0x squared plus 1x to the first power plus 0 again. Because remember, standard form means you write the highest exponent first all the way down to the constant. So even though it only says x cubed plus x over here, we're going to write the whole term out. Okay, so the next thing is we're going to do what we did last time. So x cubed divided by x, we just do the front terms. We get x squared. We take this x squared and we multiply it to these two guys. So we get x cubed plus x squared. And just like when you do long division, I'm going to subtract it. So I get 0 minus x squared, which is a negative x squared, or negative 1x squared. And then let's drop the other two terms down. Okay, so then we're going to do the process again. What is negative x squared divided by x? Well, the answer to that question is a negative 1x, which I can just write as negative x. I'm going to multiply it to both of these, so negative x squared minus 1x, but we are going to subtract this whole item right here. So the negative x squared plus x squared and positive x minus a negative, so I'm actually adding it. So I get 2x, and I'm going to bring down that plus 0 just so I have it, because we're going to do the whole process again. 2x divided by x gives me a positive 2, and then I can do 2x down here, where I'm going to write 2 times this, so I write 2x and plus 2, and then I'm going to subtract that, and I have a remainder of negative 2. So what do I do with that? Remember, I come back to the top. I write the antiderivative symbol, the integral. I write x squared minus x plus 2, and then I put the remainder over the divisor, and dx. And now we can use reverse power rule and our special function. So if I write over here, the antiderivative of x squared is x to the third over 3. The antiderivative of negative x to the first is negative x to the 2 over 2. The antiderivative plus 2 is plus 2x, and then we have our beautiful special function of the natural log of x plus 1. Don't forget the beautiful absolute value, and then don't forget your glorious plus c. So again, we look at this problem. There's more than one term in the denominator, so we're not going to be using negative exponents. U substitution is not going to be canceling anything out. So the next thing we look to do is polynomial long division. And we get our problem. Once we get our polynomial long division done, we write this on the inside. We write the remainder over the divisor, and now it is in a perfect form to be able to do your antiderivative to get your answer.